We're gonna start by going over the homework. And since a bunch of people, I know we rushed through that first one. Well, I guess it's technically the second one. I do want to go over that first one a little better, and I'm gonna get a blank copy so it's easier to see. So this first one was second one was a struggle for almost everybody. And maybe this is the one that we should have spent more time going over, because this was the trickiest one. The hardest part, and for next year or any other time I use these, I am going to make these pictures bigger. So part of the problem was this was just too small to work with. And so I do apologize for that. And if I do it again, I will make these pictures just bigger. But what you guys needed to, when you labeled, people were struggling because there was a bunch of repeat numbers. And you're like, they can't repeat, but they can. Trust the lines. So what I mean is when you were copying these onto here, well, actually, let me first label them because that's the first rule. So we have 80 and 100. So we established that this is 100. So they're going up by 20. So 80, 100. 120, 140, 160, 180. You might have wanted to label these over here as well. So this line is the 120 line. You don't have to label it because it is already labeled over there. This one's the 140, 160, 180, 200. Once you have them labeled, you put your scrap paper on. And you mark every line that touches that. So and you label it. So that first mark that I write, now it's the 120 line. Now I label sideways so I have more room to write. You guys trying to write 120 out, like left to right, you're gonna run out of space when they're this small. Even when they're bigger, it's still gonna get too squished. So there's the 120. The next line that hits is already labeled. It's 140. So I add it. And then 160, 180, 200. And this is where you got to pay attention. You have to pay attention the whole way across. But what you see here is this next line. That's still the 200 line. Yeah, it repeats. So you can't just get on a rhythm and go 100, 120, 140, 160, 180, 200, 220, 240, 260, or whatever. You have to take your time and label them according to what they really say. So now I keep going. This line, when I follow it around, is 180. This line right here, when I follow it around, is 160. And this again is where people got tripped up. The next line over, when I follow it around, is 160 again. Keep going. This line is 180, 180, 160, 140, and that's where it stops. I don't even make it over to the 120 line. This goes on the x-axis. 120, 140, 60, 180, 200, 200, 180, 160, 60, back up to 80, 80, 60, 40. So once you've got the dots, then you've got to connect them. But one thing, oh, I'm sorry. Do you need, Riley, I forgot to give you a pencil. You need one? Here, you can go grab it. No delivery today. When you're connecting them, it is important to remember that curves or hills curve at the top. But one thing I think I forgot to emphasize is not only do hills curve at the top, valleys do the same thing. A valley, when you're going down one hill and before you go up the next, isn't typically straight across. It usually bottoms out and then goes back up. So you have to see if maybe you're at a valley as you're going. So what I'm saying is, if this was the road you were taking and you went 120, 140, 160, 180, 200, you're on your way up the hill. Then you hit the 200 again. You have to ask yourself, what's happening in this space? So that space I just shaded in, is it bigger than 200 or less than 200? It's bigger. It's in between the 200. It's at the top of the hill. So I got to curve that up. And as we're walking down the hill, so we're hitting 200, 180, 160, going down the hill. But when you get to these two 160s, you got to ask yourself again, that in between space, the area right here that I'm shading in, is this less than the 160s or more than the 160s? It can't be 160, because if it was 160, it'd be straight on the line. So it's either less than 160 or greater than 160. And how you tell is you look around for another line. If this is 160 and that's 140, we must be below 160. So it's going to bottom out into a valley. So you can't go straight across and you can't hump that up like a hill. It is a valley. You need to like dig it out in a valley. Then again, we get back up to the 180 and there's two of them again. So this area, this third shaded section, that's higher than 180. And then we go back down. So your profile should have looked like this for that one, where you have up a hill, down into a valley, and then up another hill. On the Regents, how they make me grade this is they give me a clear copy of the answer key. And I put my answer key over yours. They allow you for a little bit of wiggle room, but not much. So basically what they tell me is, as long as their dot is somewhere in, they give me a big dot. So as long as your dot's somewhere in there, it's not a lot of wiggle room. So you have to be fairly accurate with this. So again, I like to draw the lines in the background. You can do that. Whatever you got to do to make sure your lines go pretty much straight above on your scrap paper. So that one, I noticed a lot of problems with that one. It was similar on the next. Where's that? This would just be easier if I, oh, there it is. The next one down, this one, a lot of people did not notice that this number started going back down. Once you hit the peak of a mountain, so this peak where they're both 100, this next line is going to go down. So that would have been 90, then 100 and 100. So your profile should have gone down, then up and back down. This one was very similar to the first one we did. So again, I would have labeled your numbers. We have 150 and 100. These ones are going up by 10. This was less messy. So this is 140, 130, 120. No, it's not. What did I miss? 100. Oh yeah, I just can't count. 110. We're counting by tens. 10, 20, 30, 40, 50. When you do your scrap paper, again, I would have found it more helpful to have these labels closer. But if you are refusing to do that, you can still handle it this way. This line right here would have been 140, 130. This line is on the 120. It's hard to see what this next line is because I didn't have it labeled, but that's on the 110. Then I hit the 110 again, 120, 120 again, and then 110. When you put these on here, 140, 30, 20, 10, 10, 20, 20, 10. A lot of people struggled. Well, am I going uphill or am I going downhill? Here, Mr. D. Sorry. So do I bottom them out like a valley? Do I curve them on the top like a hill? The best way to check that out is to imagine yourself walking. If I start at G, which is at 140, then 130, then 120, and then 110, I start off going downhill. But what about this little section right here? Is that going to be higher or lower than 120? I'm sorry, not 120, that's the 110. Higher or lower than 110?
No, it's gonna be lower.
It can't be the same.
It'll be higher.
Look at this. What is this label right here? That one's 110. This one's 110. So this section right here is in between what two lines? 100 and 110. So lower. So because this section's between 100 and 110, it is lower. That first section needs to scoop down below 110. Then you would go loop it. Then you got to ask yourself, okay, so I go up to 120, but when I'm in this section right here, am I higher than 120 or lower than 120? It is higher. So here's 120, there's 130. So we're in between the 120 and the 130. So that loops up. Oops, and then it goes back down to 110. So you should have had that going down, looping under in the valley, and then back up over the hill. All right. The last one, I tried to trick you a little bit, or more like I messed up, but you could have still done it. What did the lines go up by? 10, 0, 10, 20, 30, 40, 50. The problem was, what did the graph go up by? 20. So if the graph goes up by 20, but I need 10, where's 10? Between the 0 and the 20. So 0, 10, 20. The 30s halfway between. The 50s halfway between. So you could have still done this no problem. I checked out everybody's and yours looked good if you did it. That looks good. So the fact that it was real little, that was actually me messing up. I meant to go by tens. But you know, it was a good learning experience. The regions might not always go up by what you expect. So that is a case of make sure you read all the words, including the labels on a graph. You got to see that they went up by 20s and not up by 10s. So that's important. All right, so that wraps up drawing profiles. So like I've said a few times here, what in the world? Oh, that's this. That's kind of like, where's the plaid shirt coming from? That messed with my head there. So what do you need to be able to do? Said this about a dozen times. First, you need to be able to draw these lines. Then you need to be able to answer questions about the maps. Where's the steep side? Where's the gentle side? Which way does the river flow? You need to be able to measure how far apart 2 points are. You need to be able to label the lines, including the depressions. Then you need to draw the profiles. The very last thing you need to do is the gradient. And it turns out, I believe we skipped the notes on page 24 for gradient. So could you all flip back to page 24? The very bottom of page 24, did we leave gradient blank? Okay, so perfect. That's where we need to pick up. We need to go here. Before I actually get started, have you ever heard the word gradient used in real life? Never, I have, and it has nothing to do with what I'm talking about. How about in art class?
Yeah.
When in art have you talked about gradient? You should have. Shades, absolutely. So what for example, like if I was to, I know I can do it in Word, I don't know if I can do it here. So if I brought up the font color and go here, there's different gradients of different colors. So when I say green, there's lots of different shades of green. And that's the gradient of the colors. If you're shading, you can start with like a dark shadow and it would get lighter. So again, it's changing. It's still in the same like wheelhouse. It's still in the same idea, but it's just slightly different. It changes. Has anybody ever had to help out with the landscaping and you had to grade a yard? Anybody ever done that? A foundation? I have not done that. Can you explain what that is? There we go. So it works, it applies. So apparently, when you're setting up site work to make a foundation for a house, you have to make sure that it's flat, that the gradient or the grade is flat. Sure. And that is exactly what we're doing here. Gradient is, let's put the definition in, and we'll see how that applies to what Michael just mentioned. So gradient shows how quickly the value changes from one point to a, Gradient shows how quickly the value changes from one point to another. So put that in on the bottom of page 24. So the color gradient, it shows how much it was changing from like a real dark green to a light green. Or the gradient for the ground, you were telling us, well, did the elevation change a lot? For a foundation, you don't want it to change. If you're making a gradient on a driveway, they purposely make driveways slope a little bit. Why would you want your driveway to slope a little bit? So you don't want the water to pond on your driveway. You also don't want it to run off towards your house. So they tilt it a little bit. So to pour concrete, you need to understand gradient, which is just how much the land is changing from one point to another. Sometimes you want it to change. So for the driveway you do, for the foundation, apparently you do not. I'm assuming with that, taking your word for it. I've never built a house. Besides the gingerbread house, and that's never gone well. Okay. To make a gingerbread house? I'm thinking that your gingerbread must be pretty crispy then. Nail gun? Do you know what a gingerbread house is? With like cookie? Yeah, super glue. There we go. There is math to do for this. I know, none of us like doing the math. The good news about math and earth science is it's not usually overly complicated. Like it's normally just plug into a formula and voila, you're done. And then the extra good news, what is the good news about formulas in earth science? Who remembers?
You don't need to.
You don't need to memorize them. So this year, all the formulas you need are on the front page of your reference table. We're gonna write it on page, where are we? So sorry for the flipping. Let's head back to page 34. So I learned from my mistake and gave you a bigger space to write. So unlike profiles, for gradient, I'm giving you plenty of space to write. So first things first, I do want to add the definition here again, in case you forget to look back. Gradient is how quickly the value changes. Oh my goodness. So what's another word for how quickly something changes? Great, that is the word. So what's another word? So when we were talking about the driveway, rate, is that what you said? Yep, a rate would work. But with the driveway, yes, it's the rate of change of the driveway almost. Or with the foundation, you don't want this to happen. I don't know where I'm going with this. It's another word for how fast the land changes. Well, how much it changes elevation. No, it's probably the way I'm asking the question. This is slope.
I said slope.
I'm sorry, I didn't hear you say slope. I heard you say elevation. I definitely didn't hear you say slope. And I wasn't asking a good question. This is another word for slope, if we're talking about the land. So for elevation, this is slope. And we all know you can do slope, X over Y or Y, whatever you guys learn in math. This isn't a graph though. So we can't just plug in X over Y or whatever slope formula is. So we're going to have to use the gradient formula. And the gradient formula is on the front page of your reference table. It's right here. It's the change in field value divided by distance. Which remember what, do you guys remember what fields are?
Yeah, well.
No, in earth science, yeah. It could be the grass. All right, if you don't remember, you're gonna have to go back to page 24 again. It was the very first thing we wrote.
Generic for anything being measured.
Yep, so if we're measuring the elevation, it's going to be change in elevation. If we're measuring temperature, it's the change in temperature. If we're measuring pressure, it's the change in pressure. If we're measuring the number of pumpkins people buy, then it's the change in the number of pumpkins divided by distance. So to do this math, takes a few steps. Just like the profiles, I have room to write the 5 steps. Now officially, do you have to do the 5 steps every time? No, but I'm gonna walk you through the 5 steps, and I'm telling you, if you do these 5 steps, you can't screw up. If you try to take shortcuts, most of you will get it right. But shortcuts always lead or sometimes lead to mistakes. So if you're really good with it, you can take the shortcuts. If not, do it my way and you'll get it right. All right. Step 1, ready? Determine the contour interval and write it in for each line. Yeah, I'll just write it out. Determine the contour interval and write it in for each line. Does that first step sound familiar?
Yeah.
Should. When did we do that already?
For
For the frickin' things we just did. Yeah, what he said. For the profiles. Okay, yesterday when we were doing these, the first thing we had to do was figure out, okay, it goes from 0 to 100, 20, 40, 60, 80, 100. So it's the same step 1, which is good news because if they ask you to draw a profile, they're probably going to ask you to do gradient next. This is one of those things where they do like multiple questions. So the same first step goes for each. All right, step 2, this one's a little bit longer. It says calculate the difference between the 2 points. So calculate the difference between the 2 points that will be used to determine the gradient. So that one was a little bit longer, but you should have had plenty of room to write it. Calculate the difference. When you hear that, what pops into your brain?
Subtraction.
Subtract. So hopefully you have some room. I put that in big, capital, bold letters. I want you to put it in big, bold, highlighted, circled, whatever. Make sure you see that that just means you're going to subtract the 2 points. So I'm just going to use B minus A. So in this class, just put the bigger number first. Bigger minus smaller number. In real life, so if you're out there doing foundations, you can't always put the bigger number first. Technically, a negative number means it's going downhill. A positive number means it's going uphill. I wouldn't want those switched on my driveway. So if you're doing this in real life, make sure you follow the directions of the person explaining it to you. But for 10th grade earth science, bigger number first, minus smaller number, so that you always get a positive number. All right, step 3, measure the distance between the 2 points. So this one is distance. How do we find distance on a map? What do we use?
I forget what it's called.
Forgot what it's called. It's like we took notes on it.
A rule.
No. Riley? That little thing at the bottom, what's that called? Map scale. Measure the distance between the 2 points using the map scale. These 2 numbers are different. Difference means subtract whatever's on the map. So if it's a map of elevation, subtracting the elevation. If a map of temperature, it's subtracting the temperature. This one is how far you have to walk to get from one point to the other. So they're different, but please be careful. All right, step 4, write the formula.
I don't want to be needy.
No, be needy, because I forget. And if you can't see it, I'm sure other people can't. But I will call you out on needy. Because I think I'm hilarious. The formula, we always find them on the front page of the reference table. Gradient. This one sounds all fancy. It's the change in value. No, I'm not. It's a change in field value. Change in field value divided by distance. So change in field value, remember, we can't just say change in elevation because these maps aren't always about elevation. We can't say change in temperature because they're not always about temperature. It's a change in whatever is being measured, divided by how far apart those 2 points are. Which one of these steps did we find the change in field value? 1, 2, or 3 was a change in field value.
Two.
So is it 2 or 3? Which one is a change in the value? So hopefully you have a little bit of room left here in step 2. This is the change in field value. I'm going to circle that, change in field value. So we find the change in field value by subtracting whatever the value is at the 1 point minus the other value. Then, by the way, as long as we're at it, which one of these measures the distance between the 2? That's 3. So basically, all you got to do, and then step 5, by the way, is solve. And you can solve this by plug in numbers. Gradient equals step 2 divided by step 3. And I'm going to put a little note here. The units must be included. I think we have time to try one of these. We have all the numbers or all the directions. Let's try one of these pretty quickly. I know I'm going to kind of rush you, but we'll try one. So on page 35, we have to do step 1. What was step 1? Whew, that was awesome. That was like the Pledge of Allegiance. You said it all together, all cool like. Determine the contour interval and write it in for each line. I've got 10 and 20 labeled with 1 missing in the middle. 15. So is there anything to write in this box?
No.
No, I'm just gonna put a note labeled on map. Step 2 says to calculate the difference between the 2 points. So we got to subtract. I got A and I got B. So B minus A, which is, for this time, just work with me here, write all the steps. Will you always have to write this? No.
20 minus 0.
Not 20 minus 0, 20 minus 10, and that is 10. By the way, these are in feet. I think I forgot to tell you that. So that's 10 feet.
I went to write 10 feet and I wrote 187.
Well, that's really weird. How do I find how far apart 2 points are?
Map scale.
The map scale. Hopefully you have a piece of scrap paper handy. If not, use the side of anything. Remember to do it my way. I know a lot of people like to put their pen up there and estimate. I don't like that. I want you to put your scrap paper up there. Mark off B, mark off A. So you just have 2 little marks on your scrap paper. You bring your scrap paper to the scale and you're like, oh shoot, the scale's too small. So do you just give up and walk away? No, if you mark this off as 6, because that's what it is, that's 6 miles.
6, 7.
And
6 and a, no,
then what do I do?
estimate.
No estimating. If I now have that marked off as 6, Riley, I could extend the scale. That's too much work too. No fingers,
Oh, the slider.
just slide it over. If I now slide that 6 over to 0, now instead of this being 7, what is that? Or instead of this being 1, it's really 7. And I'm about close enough to halfway. So I would say 7.5 miles. Then I plug it into the formula, which is change divided by distance, which is 10 over 7.5, 10 feet divided by 7.5 miles. And your answer is 1.3. And what are the units? Not just feet, feet over miles. So the units, if you plugged them in there, will show up perfectly for feet over miles. We will obviously practice more of this on Monday. You have no homework. Remember, test corrections have to be done by Monday.